Welcome to Supply Chain Next with your host, Richard Donaldson. Join us as we explore the ongoing evolution of supply chain, from the challenges professionals face every day to the ongoing digital transformation of the entire value network.
And welcome to another episode of Supply Chain Next. I'm Richard Donaldson, and excited today to have Gabriel René and James Hendrickson of Versus with me today. And good morning, gentlemen, to both of you.
Good morning, Richard.
Morning, Richard. And yeah, we've got it. This is going to be a fun one because we're gonna get into both of your guys' origin stories. So we get a twofer today. Two leading kind of thought leaders in the space, especially certainly in spatial web technology, Internet of Things, but also a lot of the work you guys are doing at Versus. But like we always do, we'd love to have just a quick intro. Start with Gabriel. A little bit of an origin story around kind of who you are. Just let the audience know a little bit about your background, where that's obviously a fascinating one, and I'll let you kind of go from there.
Thank you. Well, first of all, appreciate you having us on the podcast today. Yeah. I'm Gabriel René. I'm the CEO and founder of Versus. Most of my background has been in high-tech startups and advanced R&D. So I actually started working in advanced R&D in the early 90s when I was about 19 years old in a group called CyberLab. CyberLab was sort of one of the premier advanced R&D outsource houses just outside of Silicon Valley in a little town called Santa Cruz, a little surf town called Santa Cruz. So Apple, Intel, Microsoft, and then later Google and Yahoo, InfoSeek, a lot of big companies would outsource some of their hardest problems to outsource R&D groups, and CyberLab was known for doing kind of the impossible things. So I was exposed to things like augmented and virtual reality and artificial intelligence and sensor-based systems and real-time computing in like 93, 94, 95. And
Gabriel, I don't want to fly over that, because what you're saying there, the audience might not even realize that, and I see you smiling, but 93, 94, if you're into virtual reality and augmented reality, that's before the internet really started taking off. I mean, that is a incredible time you were 20 years ahead of where anybody was thinking doing those sorts of things in 92, 93.
Yeah. So I was really privileged to have this opportunity as a young man. And I was one of the younger people on the team to be exposed to these future technologies. And, as you mentioned, the internet, the World Wide Web was really just sort of starting at that time. And what was cool about that moment for me is that, the way we get exposed to augmented virtual reality is through the Air Force, right? I mean, it started as VR, as flight simulation. AR was heads-up displays. Dr. Tom Furness at University of Washington, who's an advisor to Versus now, is pretty much considered the grandfather of both of those technologies. And he was the pioneering person that was working with the Air Force at the time. So got exposure to these ideas and to the actual tech. Simultaneously, there is this whole sci-fi cyberpunk culture thing that's happening during the late 80s, early 90s. And so the idea of these sort of immersive virtual worlds where artificial intelligence, agents are facilitating things for you. You're interacting with robots. You've got, autonomous sort of vehicles, of course, some that fly. We still aren't there yet, but holographic information. This was the cultural sort of narrative, and the idea that computers and computing networks could do transformational things to the world. Some of these stories were very cautionary. The Neil Stephenson's work and the ideas of the metaverse are actually, semi-horror stories about really the cautionary tales about the use of advanced technologies. But seeing that tech, and then also seeing the birth of the World Wide Web, where this idea of a global network where these pages, this web of pages would allow us to do all these amazing things, and some of which we could predict, and many, of course, which we didn't predict, made me start to think about how does this advanced tech work on this network that takes 5 minutes to download a JPEG. It's like a stamp size, right?
Right.
But there was still this idea that it would catch up. And then here we are today, almost 30 years later, 25, 30 years later. And that convergence of those technologies and this power and speed of the networks is what's happening. And this is sort of the the precursor. I don't want to jump the gun here because we want to get James to share his story as well. To this idea of a spatial web. And so you can see how that cross section of a web of spaces, where all these digitally mediated activities, content, devices and machines and software all working together. So that was really this quarter of a century run, becoming very familiar with all of those technologies I just mentioned, and entrepreneurial endeavors around them, to get to the point where about 2017, so 5 years ago, we partnered with my former boss from CyberLab, Dan Mapes, and co-founded Versus on the premise that, hey, everything we've been talking about for 25 plus years seems to be happening now. How do we get into the middle and really help to build some capabilities out that will help us realize this in a way that's positive and meaningful and helpful to civilization at scale? And
I'm going to switch over to James and his origin story here in a little bit, and how you guys kind of come together. But I also want to. So you mentioned Dan Mapes, and if I'm thinking here, that's your co-author of the book, The Spatial Web 3.0.
Yeah.
And you guys were thinking about this stuff back in the early 90s together, you and Dan, around what does it look like if everything's connected at a very simplistic level, right?
Yes.
And yet 30 years of that kind of progression, looking back on that, right? I'm just kind of curious, because we're here today at 2022 still thinking about connecting everything, right?
Yeah.
You were thinking about it 30 years ago, right?
Yes.
So in that context, what's taken so long for that to happen is sort of one question. And why all of a sudden now is it coming up that everyone's like, oh my gosh, yeah, let's connect everything and put the supply chain on? And why did it take 30 years for that to happen?
So I'll do the brief version of this, and we can punch deeper later. But there's two fundamental reasons, and I opened the book in a way around this. One's called Moore's Law, the other's called Metcalfe's Law. Right. And so you can actually go backwards in time and kind of predict more or less about this point in terms of the amount of, and Moore's Law basically deals with that computing power doubles roughly every 18 months or so.
Yeah.
Yeah. And Metcalfe's Law says that the value of a network is essentially a multiple of the total number of nodes. And so this came out of network theory. And so the two together get you the ability to essentially exponentially double your compute power and your value across a network. So you kind of inevitably end up with computer networks at scale. So if you look at the processing speed, you look at the network speed alone, and then you can say, what can we push through it in the beginning? Yeah, maybe text. Okay, now a JPEG. Okay, a little bit of audio. Okay, now video. Oh, now 480. Now 1080. Now, right, and so on and so forth. And so the networks and everyone, the network speed, the network connections, and the compute speed and the chips had to sort of reach a certain zenith where you could do this sort of work. Additionally, and for reasons that historians will probably make better sense of than I will today, you also have maturity around artificial intelligence, which is the same ideas that we were talking about 30 years ago. They're not that much different today. It's just that the compute power showed up. Yep. And so you could do the work. Internet of Things and the sensor systems, at scale started to become cheap enough to deploy. And so that's happening. And then there were breakthroughs in augmented and virtual reality, which are also somewhat chip related and somewhat invention related. We saw Oculus, pop up about 9 years ago. And so that the short answer is you needed the power and the speed to be able to do it. And what Dan and I figured out in 2017 was that in the early 2020s, we would kind of ride at that starting point. And I would say now today that the work that Versus have been doing is setting everyone up, and along with all of the advancements in hardware and software, et cetera, for 2025 to be the sort of meaningful kickoff where you're starting to see this thing go from not even a concept in the culture's mind to something that is now everyone is gearing towards. And you can see this partially in the metaverse narrative, and you can see other things in the sort of smart supply chain and industry 4.0 narratives. And there's a handful of perspectives on the same thing. And we haven't all decided to call it the same thing. We happen to call it the spatial web, whatever ultimate term it ends up taking. I mean, we all used to use information superhighway 96, 97, and that didn't last.
Right. But still, I think it's fascinating, though, also to recognize that sometimes, as technologists and innovators, we tend, like sci-fi, we tend to be a little bit ahead of the curve, and it takes a while to bring people along that journey, or humanity, or however deep you want to get with this. And you have to be patient. It's one thing, right? You got to be a little bit patient, and timing is everything. And how many technologies have we seen on the sides of the road, the skeletons that were just 10, 20, 30 years too early? They weren't wrong per se, but they tried to ride the wave a little bit too early, right? And they kind of missed the crest.
Yeah, and that's a great point, because when Dan and I connected back in 2017, we weren't like, hey, let's start a company and do this. We're like, hey, these trends are converging in this direction. What should we do? And really, the wave is breaking. Where do we want to be on the wave became the question. And so that was really the starting point of this phase of what has now become Versus.
Awesome. Well, let me share this. So, James, you're patiently over there. I want to get to your origin story here as well, because Gabriel's got a pretty fascinating one. But James, tell us a little bit about yourself, and more specifically, how you met Gabriel here, right? I mean, he's in Santa Cruz, thinking deep thoughts around the spatial web with Philip K. Dick and other sci-fi authors, and you're off in Pittsburgh doing your thing. How did that get together?
No, that's a great question. So thank you again, Deb, for having us. So my origins is different, but I'd say similar. Mm-hmm. So, and I think your point about how we ended up connecting, we'll talk about that and how it happened in reality. But I think there's this underlying thread that lives throughout society that I think, Gabe sort of touched on around knowing when to pick these things up and when they all started to come together. And I think that thread is what brought Gabe and I together on a lot of these things, because, we could be thinking the same thoughts a continent apart in the same way. And, these things, these ideas and these people with the ideas find each other. And that's one of the things that's amazing about the world. And that we get to apply some of our thinking on that very topic into the technology we're doing. So that's awesome as a separate discussion. So I started, I'm a child of the .com era. So I entered the .com space just towards the end, just late enough to see the glory and then have it slip through my fingers. Right. So my background is in networking. So that's the area that is strong for me. So Ethernet, ATM, so early networking technologies. But soon after that, the .com crash, I found myself at a company called Vocalect, which does speech recognition, wireless wearables for supply chain. What I frankly found my calling. This is the beginning of what I think we would call Industry 4.0 or Industry 5.0, potentially, where we're looking at the convergence of technology and humanity in a way that is beneficial and grows together and does amazing things. So the Vocalect company is probably well known to supply chain folks. That's voice-directed work in warehousing or pick by voice. So that firm is the firm that ultimately ended up, building that space. So I had a variety of different roles there, ended up running marketing and a bunch of things in product and many, many different things through that startup time. And then I left to go to Berkshire Grey to look at how robotics is doing the same thing in supply chain. So I spent some time there and then ran across Versus just after I gave a talk on what I thought was sort of forward-looking around Industry 5.0. And this was about, I think it was 2 weeks before the pandemic hit. And I gave my talk and then sat down and talked to these guys. And I was like, oh, that's what I meant to say. They had rounded out all the edges, all the things that I hadn't thought about. I was thinking more myopically through supply chain lenses, and they were looking at it holistically. And it was just an amazing synergy of bringing these ideas together.
Gotcha.
And I think we talked about before a little bit, just in passing, around how we enter supply chain. And I think in my generations before, nobody entered supply chain out of college thinking, this is the place I'm going to go. I'm going to go solve supply chain problems or logistics problems. Nobody was thinking that way. What I found from my peers, it's people who like to tackle hard problems and have a plastic way of thinking about the world where you have flexibility cognitively, and you can apply things, both abstractions and reality together. And there's just a wealth of opportunity to be able to do that within supply chain. So never intended to go there, but I'm not sure I'd ever leave it because the problems are truly universal. They're universal truths to solve within supply chain. That's what's so exciting for me about what Versus is doing, where we're starting in supply chain to solve some of these hard problems. I think supply chain sometimes gets this rap that they get technology last. And it's amazing that we're getting it first.
Yeah. Well, and great segue into kind of what you guys are doing with Versus, but I also want to kind of, both of you are hitting on something that I think is really fascinating. And I want to make sure we talk about this because at the end of the day, and Gabe, you talked about this, it's really about chips and networks, but how you apply them is almost, it's entirely ubiquitous across the entire spectrum of humanity. It's not just supply chain, but healthcare, connectivity, automotive, space travel. I mean, I can get into a lot of stuff that's going on right now that you want to be able to not only have the processing power at a chip level, right, that's just increased and smaller, but that you want to connect all that. What you do with that generically can apply to a bunch of really big things. James, to your point, supply chain is kind of the big one because it's not really connected yet. And we all know we need to connect that right now. So that kind of tees up, Gabriel, and I'll kick it over to you. What do you guys, what is Versus and what are you guys doing to kind of harness that and begin to see that both as a company, but also as a trend, right? Because that's another thing that I even think that a lot of people, like we're talking about supply chain right now, and these underlying technology connecting all that, but that connective tissue can be applied to a lot of other things.
Mm-hmm. Well, the thing that you're pointing at is what we call the spatial web. Right. And the spatial web is, simply put, not a web of pages, which is what the World Wide Web is today, but a web of spaces. And so how do you connect spaces, real and virtual and otherwise, the objects, users and activities within them, so that you can get, coordination at scale. So you can use Internet of Things and sensors to track activities in let's say a manufacturing plant or a logistics distribution center or retail environment or an entire city. That you can use artificial intelligence to actually understand those activities and those objects and the goals that you have as a business, and run predictive scenarios and essentially simulations that then produce outputs that can align with outcomes that even your best operations floor manager could never come up with. And then you want the power.
Gabe, I'm gonna sorry to interrupt because I want to double click on something here because this is and I want you to also clarify this because you're laying out, which I think is a very systematic view, and I think it's brilliant, between chips and network. That's a generic connective tissue. But you can apply AI to that, right? But that's almost like a process that sits over somewhere else, right? Because you still need to connect everything, right? The data that I crunch and the machine learning, artificial intelligence, that needs that connective tissue to be there for it to even work, right? It's a somewhat mutually exclusive technology that sometimes gets conflated with the underlying infrastructure, connective tissue things that you guys are tackling.
Yeah, it's you need to build the roads first, right? And so you need the plumbing and the roads, if you will. So that the idea behind chips and networks is that what you're looking for is the ability to compute at increasingly higher levels of computation for an increasingly lower cost, which means that the things that you can compute get smaller and smaller. Right. So if you want a tag on a box, that's tracking temperature or motion or whatever, that can process that for $2 on a box of products that's got $1,000 worth of product in it. That's a great thing to be able to have that compute power. You need it to connect to a network, so that the network piece is that you're able to compute anything and connect everything, right? And the goal of that is that you get a computer network at scale, and it reaches past the screen into the physical world to help optimize the activities that we're doing, whether that's how to manufacture or how to optimize a worker or robot inside a logistics facility, or how to route a drone or autonomous vehicle safely through a city. Those are all the same kinds of challenges. And that's what the spatial web is really about. It's not about text and media content, which is the web has done. We're even using the web today to do this live video, but it's on a rectangle. It's on a page, right? And it's just pixels, moving around. So what we need is real world objects moving around. And in order to do that, you need to be able to connect real world things. And that's not what the internet and the World Wide Web do. And so the spatial web is designed with a different kind of protocol. Protocols are the methods that essentially the basis for the roads that connect different things. That's intended to connect things in three dimensions or more, right? So how do we connect? And then these spaces can be 3-dimensional or more dimensions. And that's the idea behind the spatial web. And so Versus was really founded to develop solutions, essentially platform capabilities for us to be able to build out these sort of web spaces. Now, the common word today that everyone uses is digital twin, but we tend to think of digital twins. I would suggest this is fundamentally wrong. We think of them like Word documents. Now, here's what I mean by this. We used to have pieces of paper and we would write on them, or we would type and we put ink on the paper. You could have the Dewey Decimal System in a library and it could get you to a genre or a section, but you couldn't go from one word on one page in Moby Dick to another page, another page with another set of words on, Gone with the Wind, right? But the World Wide Web enabled a web page that had the ability to be a networked page. That page can be linked to any other page, right? And any word can be linked to any other page. And that hyperlinking between them, that was the big novel breakthrough. But when we think about digital twin today, we think of like this car in my manufacturing facility or the facility itself or whatever, but it's kind of like an atomic unit that we don't think of it as a networked object. Right. And a Word document, there were word processors where you could digitally edit a document, in the late 80s and early 90s, that were the precursors for what Tim Berners-Lee took and said, well, what if I could link those through the internet, right? And build this next layer on top of it. That's where we're going with digital twins. So digital twins, you should think of them as, let's think of them from the perspective of a space, like a warehouse. All of the objects in the digital twin are like equivalent to the text and the content on a page. Instead of it being flat, you kind of, extrapolate it into 3 dimensions. But now imagine every single one of those items can be linked and their data can be stored in any location. And so you're referencing data as a part of digital twins of other digital twins that are all networked. So that product actually came from some manufacturing plant, and then it went to the port in Taipei, and then it went to the port in Long Beach, and now it's sitting in a warehouse facility in Inglewood. Maybe as the consumer of that product, I want to be able to track that product the whole way. Maybe as a manufacturer, you want to know certain things. Maybe the distributor or the buyer need to know certain guarantees around the performance, the temperature, any number of dimensions or variables related to this thing. And we want that to be updated in real time. Well, that's what web pages are on the web today, right? And that's what the real world is going to start to look like. And the benefit and power of digital twins is not merely just a real-time representation of your facility or this object that you control, but the fact that data related to it can be updated and networked by all of the participants. And you go from that supply chain to a supply network sort of concept here, speaking for this industry. So that's really the concept of the spatial web applied to supply chain, talking about the role of digital twin, but really thinking of it as a sort of networked digital twins, all of the digital twins, and they're kind of an analog to web pages, right? And so the digital twin is the new web page of the spatial web. And what Versus is doing is enabling those digital twins to be programmable in a standardized way. So all of the creation of those digital twins can be standardized. So everyone knows, just like a web page has a very specific format. So you can format that, and you can model all of the objects in your environment in a very standardized way. And then you can design workflows using artificial intelligence that can simulate and optimize how workers move through the facility, or how you need to reslot or do capacity management, or any other sort of optimization. So the ability to use the power of Internet of Things to sense and track objects, artificial intelligence to be able to run simulations and predict outcomes, and then actually push those workflows out to human workers that are being augmented with heads-up displays and seeing content and information and directions and guidance and training in augmented reality and sort of holographically, or to robots and drones and fleets of sort of combinations of human and machine workers. And that's a powerful new sort of operating system that allows you to operate your facility and take advantage of all the latest technology in a very powerful way. And so that's why Versus was really created, was to help drive this adoption of the spatial web, and built out capabilities that would allow industries like supply chain, which is the first place we've started here, to be able to really benefit from the power of this convergence of emerging tech.
So, so many things in there, so cool. And I mean, right off the bat, and I know supply chain's big, but you start thinking about, the spatial web as it applies to really everything, right? I start thinking about healthcare. Right, is immediately things that come to mind, where I'm like, okay, let me take the same everything you just said, but apply that to the wearables. And James, this is sort of a good segue back to James, in that even in your background with wearables and sports, and healthcare, you're in supply chain now, but a lot of the spatial stuff that Gabe's referring to can be applied to other verticals. But James, let's talk for a second here about your role and perspective on kind of pick up where Gabe was talking here around how you see this technology around the spatial web, which is still developing, right? We're still talking about development of it. How does that apply from your perspective into supply chain, given all the things that we've been talking about?
Yeah, so I'm going to start by going back to one of the things Gabe said in the beginning, answering around a digital twin, because we started to see a decent number of conversations in supply chain around digital twin. And what I think was helpful for me is when I started to separate that out and to go, all right, what do you actually mean? And I think most of the time people are talking about a digital model today. And that's been great. We actually polled some of our customers and prospects and said, how many of you have done a digital twin today? And they were all like, yeah, we've done. How many have you done? I think somebody had done 14 different digital twin projects. And how many of them got what you wanted out of it? And the answer was none.
Right.
And so when you start thinking about that digital model, and then you go to a digital shadow, if you will, where you're sort of like kind of a close analogy of the real thing, but it's not quite there, right? There's some things that match up, but don't really match up. And then you move on to the actual digital twin. And when you start, at least for me, when you look at it from model to shadow to twin, you go, okay, now I can actually run my operations off this. So an operate twin, if you will. Whereas what we've largely been talking about in supply chain today is a cool digital model that we can show off to investors or to the board or to new employees or whatever, but you can't run your operations off of it. And at the end of the day, for supply chain, the only thing that matters is how does it affect operations? And how does it drive operational improvements, operational excellence? How does it drive safety? How does it drive a carbon footprint? How does it drive ethics in supply chain? That's the only thing that matters. And as you start thinking about it that way, now that digital twin, or we sort of called it a spatial twin, because to sort of separate it out from this other thing that has become just a digital model, now we can operate against it. And to your point earlier, the sky's quite literally the limit. There's nothing that you can't do or can't be improved by looking in supply chain or really anywhere in the world by looking at it through the lens of space. Right. What can we do to improve shipping or accuracy of picks or restocking or inventory count or shrinkage in the store? Literally anything, all benefits from this. And it's just a matter of how you're applying that technology in a way that is complementary to the investments that you've already done. And I think that's also a key point, right? We've all been involved in these rip and replace forklift type upgrades in supply chain that are this time it's going to actually change everything. We had our ERP and now we have our WMS and now we have our WES and now we're actually going to get to execution. We're now going to get to operations. This time when we put robots in, now we'll get there. And we get closer, we inch closer to it. And all that infrastructure, sort of like the highway, the plumbing, is all super beneficial and really helpful, but it's missing these key elements and these key aspects, which are this holistic view of how these things fit together, how they interact, and what happens when one of them misses a deadline, or what happens when something goes wrong or something goes right. And how does that supply chain, which is actually now a supply mesh, how does that actually make a difference? Right. And what do we do to apply that here? So one of the bigger challenges is where do we go first, right? Yep. Because there's so many places to go. What do we do first?
Well, you open the door here a little bit because I'm going to go back to Metcalfe's law here, right? The value of the network is directly proportional to the amount of nodes in the network, right? And so one of the challenges and the question here is you look at what you're trying to do through the spatial web and through the application of it, even in supply chain. And if end users are thinking in the context of their own supply chain, but not how it integrates in the global supply chain, right? So the question being is, as you start applying technologies here, out, and companies want to do it on their own, but they're never going to truly be able to interoperate with the global supply chain unless there's a global supply chain network that connects everything to each other. Right? Because the supply chain is everybody's integrated into one global supply chain. The $100 trillion economy is completely connected, right? And even though Chevron or Google might not think of themselves, but they actually are all competing for the same resources at the end of the day. So the question to you is, as you're kind of looking at this, you're dealing with end users even today, how do you face the idea of individual networks versus a global network that everyone kind of interoperates on?
So I'd answer it in a couple of ways, and I'd actually be interested in Gabe's response as well. But the couple of ways that I'd answer it is, first of all, and I think you touched on it, is that no one is operating a siloed supply chain. Even if they think that they are, they're either self-delusional or myopic, but they're not operating independent of everyone else. Right. They are truly so connected and so enmeshed. And if we didn't learn that lesson in 2020 and 2021, I don't know when we would have learned it. So I don't hear people talking about their own supply chain, their own value chain, as much as they're looking at it from, all right, I have to coordinate with this shipping provider or this freight forwarder or this broker, because all of these pieces need to operate together. Right. So that's the first point. The second point is going back to Metcalfe's law. Well, how does it actually work? How do you get nodes on there? Metcalfe doesn't cover that, I don't think. The nodes arrive on that network based on on the adjacencies of their peers. So as one peer joins, they go, oh, I can't, it's a fear of missing out, right? There's a FOMO effect where you have to join, but there's also an element of there's too much value in joining that network that I can't pass it up. So I have to join. And I'll take reasonable precautions when joining, right? So we're going to join a network that is not proprietary, that is not closed, that is flexible, scalable, secure, ethical, whatever those things are. There's probably a few more, but those are probably the good ones. You're not joining something that is essentially, you're not going to put yourself in a single source kind of scenario.
Right.
So you're going to take reasonable precautions, but the opportunity of joining that network is too big to pass up. Just like when supply chain joined the internet. They took those reasonable precautions and they went from, VPNs and leased lines and all that stuff to, all right, nobody thinks a second about putting something out on the cloud at this point, or very few people do.
Right. And good. And it's a great kick over to Gabriel too, because I'd love to get your thoughts on this, right? Which is even with Versus or what you guys are doing, or just in general, right? I mean, the spatial web is about connecting everything, right? And the value of that is going to go up the more that everything is connected. So
That's
how
right.
do you kind of face that build out or consultation or whatever? Because on the one hand, it's like you want to work with these Fortune 2000 or 500 or 100 companies. Like, oh, I'm going to build my own thing. It's like, well, you could do that, but then imagine the airlines if United had its own flight services network and didn't interoperate with Delta. Right? Like that would be kind of a...
Sometimes I feel like that's true, Richard.
Well, yes, fair enough. But I mean, it would be kind of a nightmare, right? So there's got to be a common platform that the schedule management and operations of these airlines works. Otherwise, literally, we'd be having accidents all over the place. But it's the same concept as applied to everything we're talking in the spatial web too, right?
Yeah. So, there history gives us some lessons here, I guess, is the easiest way to say it. There were tons of computer networks before the internet. The internet literally means the internetworking network.
Right.
Internet work.
Right.
And so the computer networks existed. They were separate. They were siloed. They were corporate. There were government ones. There were academic ones. There were different ones in different parts of the world. They did not internet work, right? And so I talk in the book about J.R. Licklider and kind of had this vision of an intergalactic computer network. Right. Which in the end, he's going to be right. With Elon and everyone jumping in rockets. I think JR's had it by the tail. But it was the idea that everyone would have access to all the information. That was kind of a simple idea. The impact that would be monumental, so civilizational upgrade. And ARPANET was built off of that concept, right? And then that became the internet. And the big breakthrough there was packet switching. How do you make it so that the routing can be dynamic and sort of fluid and doesn't need to be controlled by any one party? And that decentralized approach to it was probably really key to its adoption. And so that's what we got. Today you got a similar set of challenges and in different industries. So when we saw the World Wide Web emerge, there were a handful of siloed approaches to that kind of capability that used some of the standards but didn't really have an open network. So CompuServe, AOL, Prodigy, right? All cautionary tales, right? Like, does Facebook really want to be the AOL of the metaverse? I don't think so. I think they want to be the Yahoo of the metaverse. They want to be your homepage. They don't want to be a silo. And the reason is that model classically fails against an open network, right? Like you might have 8-year, 10-year run there and king of the mountain for a minute, but you're going to get killed and you probably won't know it until the last second. So it's a really bad, it's a bad ideological framework for long-term business. Finally, like you've got companies that have been competing, say, in the smart home space, Apple, Google, Samsung, Amazon. Classically, these guys would fight tooth and nail, to the death. And they've all just agreed to a standard and come into a group that's called Matter, so that all these smart home devices can all finally, be able to work together. And right now they don't work together. It's kind of a nightmare. You have to have 8 apps. They're on different frequencies. You can't share data across them. There isn't a network in our smart homes, even though everything's running on the internet. So I think that the truth is that smart companies recognize that siloed approach has classically failed most of 9 times out of 10, and and everyone has seen the benefit of network effects now, and so it's not an abstraction; it's something that we all understand that very intimately. How businesses plot the course there, that remains to be seen. And this is where I actually think the work that that we're doing helps to pave the road. But the touch points is not going to be, the Verse is not going to be able to be a services business for the Global 1000. This is where the Deloittes and the Accentures and the Gartners, the SIs basically need to spin up a practice around this. And we're having those conversations with them now for that reason. In the same way that they were, doing that for Salesforce and ServiceNow and Snowflake and Microsoft and SAP and Oracle and the rest. But the benefits of this are certainly significant. And I think that there's one major difference here that is kind of is a shift. And James hinted at it with the shift from sort of supply chain to supply network, but it's a shift from enterprises to ecosystems-based thinking. Yep. And the fact that we are reliant upon our supply and demand partners in any given system, having better visibility, being able to share more information in ways that we can have some trust and reliance and governance around is really going to be key to that success. And I actually think that the organizations that are going to survive the next 15, 20 years here are going to be the ones that actually lean into data sharing and lean into, so imagine me being able to segment and share certain sections of the digital twin inside my warehouse, right? If I'm someone like NRI, who's one of our customers, I've got, I don't know, how many clients are inside of like one of the DCs, James? 50, 100?
Anywhere between, it could be 100, it could be 5, right? And they have this wide variety, right? But 100 individual clients, I think they're signing something like 60 or 70 customers a year as a 3PL, which is really high number, right?
Yeah. Yep.
So imagine if you, as the seller, let's say we've started a t-shirt company and we're letting them distribute our stuff. It's all e-com based. And we wanted real-time analytics and reporting around that, around seasonality. Let's say it's sports jerseys. And like, depending on who's winning in the games, and there's real-time, who's tweeting certain things out and what's popular and which rapper wore the jersey in the latest video actually really changes our supply and demand dynamics. And we need more real-time understanding of what's coming in and what's coming out and where it's coming. You could segment that portion of the DC and just have that subdomain, right, of the DC, and have that be visible to me as the producer of those products, right? And so that's a kind of capability that gives me a real-time understanding of the environment. There's a problem in let's say Coca-Cola ships in Latin America to all of these different mom and pop liquor stores, but they never know no one ever knows the right amount to order at what time. Right. And you can imagine a really simple solution for this, which is one camera looking at the bottles, right? And or looking at the boxes in the back. And every time a bottle comes out, it just logs it. It doesn't need to go through the cash register, doesn't need to go through the accounting system. And then that's going right back to the DC. And then at some point, the thing they can start to predict, and a worker goes and grabs 3 boxes that then go into that truck that happens to be making that route. You need all the spatial information in order to know this. And then they just show up and say like, hey, you're going to need like 3. Cool. Right. And so that's a kind of ecosystem level, thinking that starts to play into this type of, when you start thinking automation, you got to think beyond automation inside. You got to start thinking not just enterprise, but extraprise levels of consideration, because that you're going to see network effects and benefits and cost savings the more that you lean into that. And that's going to be an exciting thing to watch play out here.
Well, so let me, and that's a great kind of jumping point into how I'm going to go over to James for a second and come back to you, Gabe, and how you envision, whether it's through Versus or just in general, how the spatial web connectivity is going to play out. Because, both of you are describing kind of a platform in a broad sense, right? That is accessed by all the participants. Right, because the power of it, and Gabe referred to it here, is when you lean into an open network, right? It's infinitely more powerful, valuable, right? Insightful, blah 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 blah. So, James, the question is really for you, whether through work of Versus or just in general. This is really it's an evolution of the internet itself into kind of the spatial web, as Gabe's written about, but how do you see that kind of playing out? Because it's not clear as to how the execution of that's going to happen, right? That's kind of the gazillion-dollar question that I think you guys are probably trying to figure out how to solve right now. So, James, how do you see that kind of working?
No, you're right. I mean, that's been the challenge, right, all along. I don't think anybody. I mean, maybe some people did set out to build closed networks, but lots of people set out to do that. And as Gabe talked about, it never really works in the end. But I guess the point one is that everything we're doing is very much reliant on, the shoulders of giants that came before us. So we're not throwing away the existing internet. We're not throwing away those pipes or any of those other pieces. This runs on top of that. And what it does is it enables the capability that in many cases was lacking before. Mm-hmm. And it gives the novel element here is that we're able to describe things in space. So that means that the existing providers in those in the supply chain, so that's your ERPs, so pick a SAP or your WMS, Manhattan, Blue Yonder, all the way through are describing things today in their best cases in a two-dimensional model. And so in our conversations with them, they are hungry for a three-dimensional or three-dimensional plus view of their space and of larger space. Mm-hmm. So, this is the hard part for sure. No question about it, because, the number of people you build a protocol and they will come is sometimes that happens, but usually it's through a series of happy accidents, some miracles, and a bunch of other things that occur, right? That gets a protocol adopted. But the interesting part is that nobody else is thinking about this through this larger spatial view. So when we talk to those larger providers, the host providers, they're hungry for how they can apply what we're talking about into their existing infrastructure and into those customers. So it's always a combination of serving customer needs and building some momentum on the customer side, as well as providing some opportunity on the existing provider side and building some momentum there. And those forces come together and begin that kind of that network effect growing. And that's what we're seeing happening. And so our platform, to Gabe's point, is where we're not going out and building sometimes we refer to it as ways for the warehouse, where we're directing workers through the warehouse. That's one of the applications we have today, which is great, no question about it. But if we're going to go out and say we're going to conquer the world with our ways for the warehouse picking application, that's not a big enough scale. It's not a big enough view of the world, and it's frankly limiting to us and limiting to the world, because there's a lot of people out there who have inertia for what they have today, whether it's great or whether it's adequate or whether it's terrible. The devil they know is better than the devil that they don't. Right. So in this case, by opening that up to in a flexible, open environment in which these tools can be utilized, added onto, and built at scale, that's where that value comes from. And we're looking at this as if these pieces will interoperate and play with other systems that are out there. So we're working with a customer right now. We have a pretty advanced AI system that's within what we do. But they said, look, we're not interested in your AI. We're interested in using your protocols to normalize the data so we can apply our AI. No problem. Sure. Because that gives them scale. But I know that everybody else in supply chain doesn't have this all-star lineup of AI scientists. Sure. So if they want to pull from us, they want to pull from somebody else, they want to pull from university, have at it. But there is intrinsic value in being able to plug these pieces in a way that you haven't been able to do today.
Right. Well, let me double click. I'm going to shift back to Gabe for a second here, because you opened the door, James, on a little bit again now the protocol versus some of the applications that you can apply to that protocol, right? Whether it's AI or some of the other things you're kind of referencing. But kind of a similar question back to you, Gabe, because it seems to me like one of the fundamental challenges is adoption of a Spatial 3.0 protocol, because you almost want to, in a way, I feel like open source that so that everyone adopts it. And then you can do all sorts of value added stuff on that. And I see James laughing here because you guys are probably already working on this. But so Gabe, I'm kind of back to you a little bit. Like, you've been thinking about this. So there's a protocol that needs to go out there. It sits on top of TCP/IP, whatever that may be, right? So it's TCP/IP, Spatial Web 3.0 or something like that. How do you see that kind of getting out into the wild so it becomes a part of the fabric or the platform of the internet? And then you start applying all these kind of value-added things on top of that.
Yeah, that's a very good question. And it was one that we asked ourselves, about 4 years ago. So when Dan and I kind of saw the great convergence coming, right? It kind of reminds you of the Dark Crystal. I
can already tell you're into, I had so many references to the Foundation series going on in my head because you started opening up Harry Seldon's kind of, psychohistory. And I'm like looking through history and mathematically predicting the future. But all right, that's for another show. So hold on. I'm not getting ahead of myself. Let me stay with the protocol with you here.
When you want to talk about active inference and the other work that we're doing, we can get into psychohistory.
Cool.
But the first thing we did was try to figure out, okay, well, what's the real thing that's missing? The real thing that's missing is that our ability to have computing systems model the world in the way that humans understand doesn't really exist. You can only do little pieces and little parts, and the systems can't share stuff. And so you can't easily merge, 3-dimensional scan from LiDAR with camera footage with a temperature sensor. Just no way to do it. So what we realized was that the problem was spatial, and that space needed to be a first-class citizen. But we actually realized that something like temperature is spatial, but you could argue everything is spatial. Like color is spatial. Like the density of colors of the way light refracts. Sound is spatial. It's like literally moving your eardrum. Like everything is sort of spatial. And so we started to say, what if we thought of everything as a dimension? Literally every attribute, like every word you have in the human language, what if that was like a dimension? And in AI, there's this without getting too technical, AIs build mathematical spaces. They're called vector spaces or embedded space or latent space around the attributes or properties of something. So if they say oh, that's red, then they go here's red space. And then other red things I can attach into that sort of space. And so this is how you get a lot of this is how neural nets kind of effectively work. What you need to be able to do is model any number of dimensions and model them in relationships to each other. And that's how the human brain works, right? So you actually store information in different parts of your brain that actually have addresses and links. So everything around elephant is over in an area of your brain. But it's also, elephant is nested under a bigger bubble called mammal, which is inside of something called living things versus your toaster, right? Which is not a living thing. So you've got these structures. They're kind of like maps in domains of different types in your brain. So you got elephant over here. And then over here, you've got top hat. And maybe nearby you've got monocle, because those are things that fashion. And when I go if I go a purple elephant wearing a top hat and monocle, you can access all those as if they were locations with web addresses, but in your brain, and merge those together into a model of in this case, a colorful elephant with a sartorial penchant for fashion. So what you need to do is make it so that AI can do the same thing, because that's how humans operate. And then there's all these there's both physics-based reasoning and logic-based reasoning. We need to combine those. So we invented a language called hyperspatial modeling language. And hyperspatial means any number of dimensions. So I can have model temperature, and I can model color, and I can model shape, and I can model size, and I can model anything that we have for language. And now you can do this in a computational way. And we went to the IEEE, which is the largest standards body in the world. And we spoke to them for a year, senior leadership, and told them what we're doing. And then we presented the work and said, okay, we've cracked the code on how to do this. Essentially, how do we model human reality in a way that machines can understand, so that then we can get the benefit of those machines in our reality. And they designated this a public imperative, which is their highest designation. We donated that intellectual property to the IEEE. It's a public asset now, free of any royalties. And there's 100 members in that working group now from all over the world, people from various governments and finance ministries, Federal Reserve, large corporations, manufacturing, supply chain, ethics groups that are all going through the process of finalizing and ratifying that standard. So just like Bluetooth and Wi-Fi and Ethernet, which are other, IEEE standards, HSML, which is hyperspatial modeling language, and HSTP, which is hyperspatial transaction protocol, analogs to HTML and HTTP, right? But instead of hypertext, it's hyperspace, and hyperspace means n-dimensional. So the ability to model the human world in a machine-friendly way was the invention that we needed to crack. From that, you could get all the additional benefits. And so Versus as a company is building out their COSM platform, running on a proto version of the standards. And then our current applications like Wayfinder and others that we're deploying into, say, warehouses and other facilities today are running on top of the proto version of those standards. So we're already testing that capability and seeing the benefits of it in the real world now. And we have essentially given away that base level capability, that base level protocol as an open standard for everybody to be able to use.
And is that standard being applied at the discrete unit or node level? Or is it a protocol that sits on top of TCP/IP? Sorry to get geeky here, but I can't help myself. So, is it where does the protocol sit in the stack?
It's higher in the stack, but it's also transport layer agnostic.
Got it.
So it could work over Bluetooth and over TCP/IP or MQTT over the IoT space. So it doesn't matter it doesn't replace, as James sort of hinted at, for those transport. HTTP is also has its own advantages. But those are inherently an IP address is a one-dimensional address.
Right.
It doesn't, right? And HTTP is looking for a web page, which is a two-dimensional object. But what I need is a three-dimensional or more type of address. So I know so I can put an address at this point in space and say, I need you to put something here, right? I need you to go get something here. And so that was one of the things that was really missing. What we realized, you could extrapolate that into things like financial space, like money over time, right? Those are two different dimensions, time dimension and money dimension. And I want to be there, right? I want to have more money within less time. And now you can, with our platform COSM, built on top of the spatial web standards, you'll have the ability to then optimize for that. And that's effectively what's happening now. We've got an AI assistant that's routing workers more intelligently, more effectively through like a multi, sort of wave pick through a facility and saying, well, you got 20 picks to do. Here's the perfect route to do that. Right. Well, if that's not more money over time, I don't know what is. So it's literally optimizing, and then optimizing reslotting in the facility based on the frequency of picks and the value of the cost per pick based on the customer and how much money you're making. And so, having the power of artificial intelligence at full tilt, it's kind of one of the main benefits of the spatial web and of our COSM platform. It's going to let you, and then it's going to let you to have AIs that collaborate with other AIs and other AI assistants and agents from different organizations, different partners in the supply mesh, and they'll negotiate in the same way that, by the way, this is a rough version of what happens in the financial markets every day. There's these little bots negotiating and trading. It's not two people doing that anymore. Well, you want the same thing across the supply chain in sort of a real-time trading environment, but with all the physical activity that goes with it being able to be monitored and tracked and optimized. Right.
Super cool. Well, and again, I'm going to come back to you, James, here for a second. And like I said at the beginning, before we even started recording, an hour goes by much faster than you realize. I'm sitting here looking at this going, holy crap, again, like 60 minutes flew by. But James, just to sort of wind up here a little bit, talk about like how people can learn a little bit more about what you guys are doing at Versus and where kinds of things are at, what's kind of coming up for you guys for the next 6 months. Now that we're opening up, getting back and kind of back to normal world stuff, right? Are you guys doing a bunch of things this fall, beginning of the year?
Yeah. So a couple things. One I'll add in here because I want to make sure you heard it. What Gabe was talking about with three-dimensional plus space. Sometimes we refer to it as n-dimensional space. When you start looking at that world, adding in temperature sensing or light sensing or robotics into that, it now becomes easy.
Right.
And you know as well as anybody, right? Adding in those types of things before was a monumental task, right? Because the architecture wasn't designed for that. So just wanted to point that point out. So obviously you can find out a lot about what we're doing at versus.io. I'd also recommend the Spatial Web Foundation if you want to geek out a little bit more about what we've been talking about. And as a personal recommendation, I think it's fascinating to go through that IEEE process. Right. Here are the people that we have speaking on that. Here, the smartest people in the world today talking about these things seriously and trying to solve problems seriously for humanity in the future is both humbling and exciting and empowering. So if you've never been involved in one of those standards bodies, this is a great one to get involved in and listen into. I know that sounds like a hard sell to say that you want to go sit in on a standards body, but to me, these folks are truly the smartest people in the world, working tirelessly to, and I don't mean Gabe, I mean, he certainly is, but it's people from all over the world, unrelated to what we're doing at Versus, trying to make this an amazing, great place. Yeah. And then in terms of shows, we're at CSCMP next week. Nice. And we'll be doing, the usual wave of supply chain shows throughout the rest of this year and into next year. So you should see a lot more of us. And in fact, if we do this right, you should be going, where did these guys come from? And why are they everywhere? And it's because that convergence of need has hit.
Yep. And it's also because you guys are out there. You've launched the Spatial Web Protocol and it's connecting everything. So you guys are right behind that. So Gabe, I'm going to come back to you and sort of close things off here a little bit. Beyond the book that just came out, Spatial Web and Versus, of course, and even kind of going back full circle to when you started, early 90s, thinking about this connected stuff. I mean, where do you see things? Just, few thoughts here and kind of what's coming up that's going to be, gets you really excited about the almost not conclusion, but 35 years in the making of bringing the spatial web to what you can now see is like, it's actually starting to happen.
Where we stand right now, kind of coming into the end of 2022, I'm looking at 2025 as the kind of the end of this phase. It'll probably be 95 to 2025 when we'll look back on it. So kind of a 30-year run there, where the foundational pieces are in place, operational, have meaningful traction, and it really becomes more about scale at that point. To be honest, beyond that, it's all about what's classically called artificial general intelligence, or AGI. And so we believe that the fabric that we're building, it becomes the sort of digital intelligence scaffolding upon which what's been classically referred to as AGI, which for folks that are listening don't know, it's when it's sort of artificial super intelligence, right? To the point where AIs are able to have more than human level intelligence. Now, often this is sort of expressed as like some sort of like a singleton, like a single AI that's operating the whole planet, right? And you get this sort of Skynet and Ultron type, fears around that stuff. That's not what we're talking about. What we're talking about is something more akin to a hive or a swarm of starlings, the way that sort of biological and natural intelligence is able to operate and coordinate things at massive scale without like a single thing in charge. And so that's what these capabilities are. The supply chain digitized, and the power of AI, many AIs working together is going to give you something akin to a kind of nervous system for the planet and a sort of neocortex to help guide it. At that point, then you can start to tackle these, what's called hyper objects, the things that we are personally aware of, but have no real sense of how to address like climate change and global pandemics and then social equity and global economic, disparities. We're going to need the horsepower of these kinds of technologies aimed in that direction. And if it's really important that we can express and that it's understandable to these AIs, what human values are, what human ethics are about. And even as we work through those challenges ourselves, they got to have a baseline for that isn't completely alien or foreign. And that's why the protocol stuff that we've been doing is so important, because we do that today through language, right?
Right.
And so that what we've invented is a language to be able to really share humanity's knowledge map with our digital systems. I won't get into anything as abstract as artificial consciousness. I'm not even sure what human consciousness is, but as an extremely advanced set of tools that can work together under our guidance to achieve the sort of ultimate set of goals that I think we have as a civilization. And not without a lot of existential, crises that we're facing, sort of meta crisis level stuff at this point. It's a bit like a sci-fi story itself that we wake up to every day. So totally. How do we make sure that we're the collective heroes of that story and try to move things in a direction that have a healthy outcomes? That's our bigger, broader focus beyond merely having a successful business, and that's part of the core values of Versus as an organization, and plays a part in everything that we do.
That's awesome. Well, that's a great way to end up there. And I can't thank both of you guys enough for being on here. Like I said, it was going to be, hopefully we get a chance to tune in again. But you guys are open to networking on LinkedIn. We got everything on the Spatial Web that's out there, obviously Versus the website, but really a pleasure having both of you here today, and just a lot of fun. Good conversation.
Yeah, great to be here. Thank you, Richard.
Thank you.
Thanks for listening. If you have any comments about this episode or topics on supply chain you'd like us to cover, you can reach us at supplychainnext@requis.com. And while you're at it, check out the Requis platform at supplychain.requis.com. Requis allows you to manage the full asset lifecycle in the cloud while collaborating with your entire value network to buy, manage, and sell your assets. Find out more at requis.com.